Dear students, hello and welcome to our virtual chemistry class. This is Mohammad Asif Iqbal, Senior Teacher, Department of Chemistry, Milestone College. In this class, I am going to discuss about Chapter 9, Acid-Base Balance. This is the fourth lecture of that chapter. Dear students, in this class, I am going to discuss about the acid rain. We know oxide of different metal when react with atmospheric water, it produce different types of acids. Pure air is a mixture of small amount of carbon dioxide gas. This carbon dioxide gas when react with atmospheric oxygen, it produce carbonic acid. During the storm, thunderstrike take place in the air, and this thunderstrike produce 3000 degrees Celsius temperature. In this temperature, inert nitrogen gas break down and produce nitric oxide with reaction of oxygen. This nitric oxide oxidized by the atmospheric oxygen and produce nitrogen dioxide. And then nitrogen dioxide react with atmospheric water and produce nitrous acid and nitric acid. This carbonic acid, nitrous acid and nitric acid reduce the pH value of rainwater. Now, what is the pH value of rainwater? The pH value of rainwater is between 5 to 6. That means the pH, the rainwater is little bit acidic. Now, what actually acid rain is? Due to the different human activities, we use coal and petroleum to run industries, power plant and vehicle. And this coal and petroleum contain sulfur and nitrogen. When we burn this petroleum and coal, sulfur dioxide and nitric oxide produce. The sulfur dioxide and nitric oxide react with atmospheric water and produce sulfuric acid, sulfurous acid and nitric acid that cause the reduced pH value of rainwater, and the pH value of rainwater become 4 or less than 4. That rainwater is known as acid rain. Now you can see the definition of acid rain. When pH value of atmospheric precipitation rain become 4 or less than 4, then that precipitation is called acid rain. I repeat once again, when pH value of atmospheric precipitation rain becomes 4 or less than 4, then that precipitation is called acid rain. So the main acids which are cause the acid rain are sulfurous acid, sulfuric acid and nitric acid. And what is the consequence of acid rain? The consequence of acid rain is very severe. When acid rain fall into the soil, it reduces the pH value of the soil, and consequently the fertility of soil reduce, which cause the less production of crops. And when acid rain fall into the marble structure, different types of sculpture and building, it erode these structures. In this part, I am going to discuss about water pollution. We know pure water is known as life. Due to our different activities, we polluted the water, and among this pollution, one of the pollution is making hard water. Now, what actually hard water is? the hard water that contain large amount of divalent cation like calcium, magnesium and iron. I repeat once again the definition of hard water. Water that contain large amount of divalent cations ion, calcium, magnesium and ferrous ion is called hard water. So what types of problem hard water can create it? These ions create many problems while using the hard water, especially when we try to clean the dirt from the clothes by using hard water. The hard water hindered the soap to form the foam. We all know the sodium and potassium stearate is known as the soap. When we dissolve sodium and potassium stearate, it produces free stearate ion which cause foam. But when we dissolve the soap in hard water, calcium and magnesium instantly react with stearate ion and produce calcium stearate and magnesium stearate, which hinder the forming the foam, and consequently the dirt of the cloth cannot be cleaned. Now I am going to show you how the stearate ion react with calcium and magnesium salt. We know the formula of soap is C17H35COO, which is stearate ion, and this is known as soap. When react with calcium or magnesium salt, it produces calcium stearate and salt. Due to the formation of calcium stearate, foam does not form in hard water. Hard water also cause different types of problem. It create layer inside the pipeline and obstruct the flow of water. It also create problem in boiler, and we experienced boiler explosion in different types of industry in our country due to the hardness of water. Now students, how can we remove the hardness of water? As we know, there are two types of hard water: temporary hard water, permanent hard water. The process of removing hardness is also two types. For the temporary hard water, we know this hardness is caused due to the presence of bicarbonate salt. When we add heat in temporary hard water, it produces carbonate salt, carbon dioxide gas and water. This carbonate salt does not dissolve in water, and consequently it precipitated at the bottom of the container, and we can easily remove this part by filtering the water. And for the permanent hardness of water, what can we do? We can add metal carbonate salt like sodium carbonate salt in permanent hard water. When we add sodium carbonate salt in permanent hard water, it instantly reacts with calcium, magnesium, chloride and sulfate salt and produce calcium carbonate and magnesium carbonate. These two carbonate does not dissolve in water, and consequently they create the precipitation, and this precipitation go at the bottom of the container, and we can also remove this part by filtering the water. Now students, you can see what actually happening in the case of temporary hardness. We know the temporary hardness is due to the presence of bicarbonate salt of calcium or magnesium. When we apply heat, this bicarbonate salt turn into carbonate salt, carbon dioxide gas and water. This carbonate salt does not dissolve in water, and when it go at the bottom of the container, the water is removed from temporary hardness. Now come to the second part, how we can remove permanent hardness. Now students, you can see that chloride salt of calcium and magnesium and sulfate of salt of calcium and magnesium cause permanent hardness. When we add sodium carbonate, it will produce calcium carbonate, which cannot dissolve in water, and at the same time it will produce sodium chloride salt. Now by adding the carbonate, sodium carbonate in hard water, hardness of water removed by forming calcium carbonate and magnesium carbonate. Dear students, the another name of pure water is life. The maximum portion of living body is water. So drinking pure water, using pure water is compulsory for living being. Due to our different activities, we make different types of polluted water, and testing the polluted water is extremely important for our survival. So how we can test the pure water, or what are the testing procedure to identify whether this water is pure or not? Now I'm going to write down some steps. By this way we can assure that this water is pure water. Number 1, color and odor observation. We know pure water does not possess any color. It is transparent and odorless. There are very few amount of minerals are present in pure water, but the amount when become greater, then this water is considered as polluted water. And if the color of the water is changed, or any odor is found from the water, or any suspended particle are observed in water, that water is actually polluted water. So by observing the color of the water and flavor, we can assure that this is a pure water. Number 2, temperature of water. In the summer, the temperature become 30 to 35 degree in every water reservoir in our country, especially in pond, river and canal. But when the temperature of water become more than 40 degrees Celsius, then that water is considered as polluted water. This polluted water is created in different types of power plant, where power plant water is used to cool down the power plant, and this hot water come to the water reservoir and make the temperature of water higher, and which cause serious problem in aquatic life. Number 3 one is pH value of water. We know the normal pH value of water is 4 to 5 to 9.5. Anything less than 4 or anything greater than 9.5 is considered polluted water, and it is extremely threatening for the living being. And the last one is biological oxygen demand, BOD, and observing the COD. Now I am going to discuss elaborately what BOD and COD mean. Now the elaboration form of BOD is biological oxygen demand, and the elaboration of COD is chemical oxygen demand. Now what actually biological oxygen demand mean? The total amount of oxygen which is required to decompose all the organic compound in water body is known as biological oxygen demand, and the total amount of oxygen required to decompose all organic and inorganic compounds in an water body is called chemical oxygen demand. Now students, as the amount of organic and inorganic compound presence in water increases, that water is considered as polluted water. That imply if the value of biological oxygen demand is higher, then that water is polluted water. Similarly, when the chemical oxygen demand of a water body is greater, that also considered a polluted water. Between BOD and COD, COD is always greater than BOD because COD indicate that the amount of oxygen which is required to decompose all organic and inorganic compound. On the other hand, for BOD, we need to decompose organic compounds. Purification of water is very important to drink pure water, and there are several methods to purify the water, and these methods are, you can see, chlorination, boiling, sedimentation and filtration. Now come to the first point, chlorination. This is the easiest method to sterilization of water. When we add bleaching powder in water, it oxidizes and destroys the germ and water become sterilized. And the second method by which we can sterilize the water is boiling. If we boil the water at least 15 to 20 minutes, the water become sterilized and germ free. And the third one is sedimentation. This is another method. In sedimentation process, we add alum dust in water. So what is the formula of alum dust? You can see potassium sulfate, aluminum sulfate with 24 molecules of water. This is alum dust. When we add alum dust in water and keep the water half an hour, this alum dust with all the impurities sedimented at the bottom of the container. By taking the upper layer of water, we can get pure water. And at the last, this is not last but not least, is filtration. In recent days, we use different types of filtration process. Thank you for being with me and hope that you understood all the topics discussed in the lecture. If you have any problem, ask the question to your respective subject teacher, and hope see you